Okay, so this will be first part, it's section 2.4, part 1, and we're going to be talking about chain rule. Chain rule is used on composite functions, all right, and you've messed with these before. These are things like fog and off. If you remember, fog is where I take G and put it inside of F. Okay, and we're going to approach these with the same basic idea. The chain rule you use when you have a function inside of a function. Or think of it as you've got a function within a function. Okay, and it deals with composited functions. So as usual, probably the best way to attack this is to actually, let's go through and do an example of how to do this before I actually write out what chain rule is. So let's take a look at y equals cosine of 3x. All right, now we know what cosine is, but if you take a look at this thing, I have a function inside of here, which is 3x. So we're going to call this function inside of it u. All right? So really what I'm trying to do is find cosine of u. And what chain rule does is y prime then is going to be equal to the derivative of u, in other words, the derivative of the stuff inside of here, times the derivative with respect to u of your function with u in it. So in other words, instead of a 3x now, I'm going to put a u in its place. So let's come in and take a look at how we actually do something like this. So here's my function. So I want to have u is 3x. I need u prime. If you can't look at this and tell that it's 3x at this point, you haven't been getting enough practice. You've been letting someone else do your work for you. Okay, so now what I do then is I'm going to have u prime, which is 3. Okay, now my original function, if you remember right, up on top was cosine of 3x. So now I want to find d du of cosine of u, and I'm going to replace my 3x with a u. All right, well, so the cosine of that is negative sine. Now I come back in, I'm going to replace my u back in here. So my derivative now, and it's the first derivative, is going to be negative 3 times the sine of 3x. And if you take a look, what's happened is we've taken the derivative of the inside part, which was here, and then we've taken the derivative of the outside part, which was this, but we don't redo this because we've already taken the derivative of it. Okay. And so that's our derivative. And if you take a look, what happens is we moved, or you can think I started from inside. This is the function that's been composited inside of that. So if we went in, we wanted to, let's go back to our original function, which was y equals cosine of 3x, and this is another way of looking at this problem. And you remember we went back through this, so I would have f would be cosine of x, g would be 3x. So what I've got here now, y is going to be fog of these two things right here. okay? And you take the derivative of this, and then you're taking the derivative of this thing on the outside. All right. And chain rule, you can think of it as basically what we're doing is we're linking these things. We're taking the derivative of the inside, and then we're linking or multiplying it with the derivative of my outside term. So let's take a look at another example. Here I have g of x equals 3 times 4 minus 9x to the 4th. This one looks kind of scary. We want to find the derivative. All right, so this is a constant multiplying. Let's pull it out of our calculus. Times d dx of 4 minus 9x to the 4th. So if you take a look at this, this is a composited function. There's my inside part, and then here is my outside part. So I'm going to do u will be equal to 4 minus 9x. U prime, the derivative of u is negative 9. So what I've got now then is my g prime of x is going to equal to 3 times, and we've got all this mess here. So I'm going to have a negative 9 times d du, and remember I'm going to replace that with a u times u to the 4th. All right, this is just simple power rule. So now I'm going to have 3 times negative 9 times power rule on this 4 u to the 3rd. Okay, so now I come back and I'm going to substitute back in. I'm going to have 3 times a bunch of mess, and my u was 4 minus 9x to the 3rd. And now what I'm going to do is go ahead and distribute on in. So 3 times 4 is 12. Times negative 9 be 108. So I've got a negative 108 times 4 minus 9x cubed. And that is our derivative. Okay, this is chain rule. Let's take a look at one more. Y equals 1 over square root of x plus 2. If you don't recognize the need right now to rewrite this as rational, you're really in trouble. So I've got x plus 2 to the negative 1 half. And again, I'm still dealing with a composited function. There's the inside part, and there's the big part. I'm going to come back in. Remember, we pulled the inside part out, and let's call it u. So u is going to be x plus 2. U prime is 1. Okay, so now we come back in, and y prime now is going to be equal to, remember right, it's u prime times d du of this function right here, so it will be u to the negative 1 half. Okay, so now we come back in and we substitute back in. U prime is 1. Well, that's easy. Take the derivative of this. It's going to be negative 1/2 u, and then I subtract 2 halves, negative 3 halves. And I substitute back in for u, which was x plus 2. It's going to be negative 1 over 2 times, and I'm going to have the square root of x plus 2 cubed. And you can simplify this out a little bit more. I'm going to show you what this looks like. I haven't made an issue of it up until now. This is probably a good time to start pushing it. So I've got negative 1 over 2. And I'm going to have the square root of x plus 2 squared times the square root of x plus 2. And that's the same as the square root of x plus 2 to the cube. Square and square root cancel each other out here. So that gives me negative 1 over 2 times x plus 2 times the square root of x plus 2, which will give me negative 1 over 2x plus 4 times the square root of x plus 2, and that's where you stop. And right there is the answer for this guy right in there. And that's chain rule.